Hello, hello, hello. Hope you're all doing very well. Today we have a very interesting one to show you. Today we're going to talk about flexible electronics and a bit of a different thing that compared to what you're used to seeing here. But basically, I've got an image here of a board I don't know if you could call it a board. It's like a piece of paper I've designed, and as you can tell, did this quite early on. So no, it's quite a while back now. And if you've done like these type of things, these like polyimide type flexible things, then you can see everything that's wrong with it already. But let's get into it, shall we? If you can see that there, that is the circuit itself. You can see how incredibly thin it is. It's absolutely thin. I didn't put any components on it because it doesn't work. So I don't want to waste components. And you could just see this is actually two layers. Well, there's a bottom layer and then there's a top layer, so two layers. And we're going to talk about it today and how these things. So this is a process. You can find out more about it. It's literally just called flex print, and it's a bit different from printed. With printed electronics, usually you have a thin substrate, usually a plastic or whatnot. You see them use the PET rolls and whatnot, and you would deposit some conductive ink on top of it, and you'd have like a thin separate layer of a dielectric on it. So with the amount of professionalism I have, and I do apologize for these type of things, here is an example of a printed electronic. Just nicked this off Google, and I'll go through the explanation for those of you who haven't seen it. It's an interesting technology, really. So what you have, the top layer here is the dielectric. What you have for the top layer is the silver ink that is running across throughout the entirety of the circuit, and as you can see, it's connected to the pads here. And if you notice it, this would probably be the ground pin of this micro, and that's why it's connected to the exposed pad, because you can't actually put a ground layer compared to just regular PCB boards. So all your tracks has to be connected. That's usually how I would do it. I'm not too sure about it now. Maybe you could put a ground if you manage to spread silver all around it and have that grounded, but we'll see about it. But that's usually how it's done. And this green thing here is the dielectric. So this would be acting as your vias almost, to prevent a short in between your bottom and top layer. So you could see here they've got a dielectric running across here and separating the top layer and the bottom layer. So this prevents shorts occurring. Coming back to this one, this is done on a polyimide film. You can see it's much different. There's not a dielectric within it. You can just see it's instead these black lines going across, and this is actually the bottom layer of the board. So when I had done this design, and what you'll see here, that this film is actually, you could put vias through them, because it is essentially a thin PCB board in quite bare bones. It's quite literally that. I'm not too sure about the manufacturing process whatsoever. I've just heard that it's a very disgusting, messy process that goes through a bunch of copper and a reel, and you get this orangey look to it. Of course, correct me if I'm wrong. And you can see these squares here. Now these are not actually, so I will circle that for you whilst I try and figure out how to use paint. So these things over here, and so you can see them, you see them, so you get the point. And I think, what are they? You must thought they are vias. Oh, it's like that dielectric thing. How is it actually transferring the connectivity from your top layer to bottom layer? Well, for this case, it was supposed to be vias, but I hadn't changed it at the time. A major mistake on my part. And instead put these pads. So if we go back to the print electronics, you can see like these pads here. So these might be the connection points between the two layers. So you'd print the bottom layer first, place your dielectric, and then print the top layer, and thus making a connection in between the top and bottom layer through these pads. I had not done that, so I instead just got two separate layers without any connectivity through it whatsoever. So I had not done it, I hadn't got any connectivity whatsoever through it. And that was the first mistake I made with it. So even the JTAG connectors, I had not put a hole through them, so they've still left the tags here. So instead they've just created a footprint of itself, of just laying down metal on there, which is a fault on my part, of course, and not the manufacturers. I should have checked and actually understood the process a bit more, which is always very important before you actually do something. Always understand the process. So with this is, as you can see, it's really highly flexible, and I'll try and get an example with actually components on to show you. You can actually bend this in. So it allows for really cool applications, and this is not something that's new. This is actually something that's been around for quite some time. So if you look in between your display cases, maybe your monitor, or even a good one would be the OLED screens that you can get with the ribbon connectors, those are actually using the same kind of technology. So it has been around for quite a while. It's nothing new, but I guess over time the process has gotten a lot better. I'm not too sure on the limitations of this, but I would like to know if you can go to maybe further layer boards and whatnot. I had seen I actually had the opportunity to visit a PCB manufacturer a while back too, and they're saying about this project that they had, and it's nothing new really, but it's quite interesting, and it was about placing, it was for use to track animals and when birds migrate and whatnot, and they did a 4-layer board, but it was incredibly thin, and you could bend it just like this, just like so. And it was a 4-layer board, so it was quite incredible to see that we actually have that capability. And as you can see, because you do not have a ground plane or a power plane, your routing abilities get put to the test into how well you can design a board. In this case, it was a lot better than the first attempt. The first attempt was just a spaghetti mess, but this was a lot more neater. It's a lot more cleaner, I would say. But of course, you still get these weird things like here I've done teardrop, is it what you call them? Things here. I could have made all the orientations right for ease of manufacturability, maybe all the components the same way, and just making it easier to manufacture. Essentially, these test points are quite big. I could have really used smaller ones to save space and overall reduce the space of this board entirely, though I wouldn't know, because there's supposed to be a battery that goes along here, so I was quite constrained to that point. The test points, they could have been labeled instead of putting TP5 or whatever. Then what would happen is you would have to put different labels to what you're actually measuring, and this makes it incredibly inconvenient when you actually come to test these things. You're always having to read against the schematic and whatnot. I guess it's just for ease, make your life easier. And just another quick one before I end off. I think I actually got these things wrong when I made them. I think they're actually flipped. When I first designed, I kept spamming the X and Y button. Then for those who don't use Altium or whatever, it flips the component. So essentially everything was mirrored and unplaceable. So everything looked like it was placed on the bottom side of the board, which in this case, it wouldn't have worked whatsoever. So the footprint still said it was like, oh, this is the top layer board and whatever. This is, when you are looking to mirroring this layout, do you sure want to continue? I completely ignored that warning and just proceeded on. So do read the warnings also. So I'll be hoping to get a actual sample in with components placed on them, and we can actually take a look on how well these things actually do, and if you can actually pop off components before the thing starts breaking. So look forward to that.